Hello, I'm Anna Mackay and today we're looking at scientific notation. So that's in the form of a multiplied by 10 to the power of k. And the conditions that have to be met are that a has to be between 1 and 10. Now it can include 1, but it has to be less than 10. Because technically if it was 10, you could rewrite that in a different scientific notation form by moving the decimal over. This will make sense as we do some examples. And k must be an integer, so a whole number for that. Okay, so if we're asked to write this in scientific notation, so some things to get your head around. There's concepts where we talk about jumping the decimal place. So currently ask yourself, well, where is the decimal? It's currently at the end here, we can't see it. And that's just maths convention. If you have the number 9, we know that that's technically equal to 9.0. That's something that we know. So it's here and we need to move the decimal so that the number at the beginning, the A number, is between 1 and 10. So you think about where that decimal could go. Well, if I put it here, it's 944.88. Is that number between 1 and 10? No. So you keep moving it until it is. That would be 94 point something. Here it needs to go 9.4488. So that's our aim. Now, in terms of what this number actually is, you might like to think of it as this to start with, 9.4488 multiplied by what number would give us that? So it's 1 with how many zeros? It would be 9. 4, 5, 6, 7, 8, 9. If you don't believe me, get your calculator out and check that. If you multiply this number by 1 billion, you would get this number because it's 9,448,800,000. So now it might be easier to see how it's going to end up in this form. You now need to write this number here as 10 to the power of an integer. So that's going to be written as 10 to the power of how many zeros are there. So we have 9, so it's 10 to the power of 9. And that's written in scientific notation. If you have your calculators, you can always check that. You can type that number into your calculator, hit equals, and see if you get that number, and then you'll believe me. Now, scientific notation is used to write really big numbers in a shorter way, if you like. So that's an example of a really big number. What about really small numbers, like this one here? So something could be a measurement of cells or something microscopically small. So that we don't have to write that number out with so many zeros, this is where scientific notation comes in handy. So our goal is to get the number at the beginning, so the A number, as a number that's between 1 and 10. So if you just start looking at the number components here, the non-zero integers, you've got 5304. So if the decimal's here, eventually we need to move it closer to these numbers. If we put it in here, it's 0.5. Well, that number, although it's above 0, it's not greater than 1, and that's what we need. So if we put it here, it would be 53. That doesn't meet the conditions. So the decimal is going to sit between the 5 and the 3. To understand, often with scientific notation, the thing that tricks people is it a positive power or a negative power? And positive powers imply big numbers, and negative powers imply small numbers. Just going to work you through how else to think about this number. So technically, it's the number 5.304 divided by a number with lots of zeros. Now, how many zeros would that be? It would be 8 zeros by my count, because let's think about that. Here's the decimal here. If we jump it in 3, then 6, 7, 8 places to get between the 5 and the 3. And so it's a divide. That's also therefore equivalent to, let's write it in fraction form. So there it is in fraction form. Let's think about that 100 million number as a 10 to the power of something. What would it be? 10 to the power of 8, because there's 8 zeros there. Now, if you were to write that without, the 10 number there, instead of the 8 at the bottom, let's bring that up so it's sitting next to the 5.3 number. Now, our laws of powers tell us that if it shifts from the denominator to the numerator, the power instead of being positive, would become negative. So we can write this as 5.304 multiplied by 10 to the power of negative 8. So when you usually do scientific notation, you move straight from this one, the question, into the answer here. But this is a bit of the background information as to why it's equal to that. So it's a negative power, and that equated to a really small number. And the same process can be used when you're going backwards, of course. And one more here. What about when you get things like this, 4.62? Well, you have to write it as a number multiplied by 10 to the power of something. And the question mark is, what's that something? Is it a number already between 1 and 10? Yes, it is. So how many places is that decimal going to shift? None, you might say. So technically, it's 4.62 times by 1, because nothing needs to happen. So I ask you, what power of 10 do you need to get the answer to be 1? Well, the answer is 0. So the answer to this is 4.62 times by 10 to the power of 0. Check that in your calculator if you're not sure. Now, using our calculator to evaluate these things. So have it handy, type it in. What do you get? Something along the lines of this. So there's the number typed in and here's our answer. And you need to understand what this is. You cannot write down that answer onto your page with an E and a plus 13. That doesn't show an understanding of scientific notation. What you need to understand is this E is the exponent, which is the power of 10. So the way to write this out is 8.265, a multiply, and base 10 to the power of 13. Next one, a divide. Grab your calculator, type that in, and your screen should give you something along the lines of this, 7.75, the exponent of negative 10 this time round. So you're going to write 7.75 multiplied by 10 to the power of negative 10. We're asked to evaluate this number here, writing our answer in scientific notation correct to 3 significant figures. So typing that in and see what you get. This number here, and as our friend tells us, significant figures, the first one is the figure, the leftmost non-zero digit. So that's your first significant figure. And so what's on the left? We have a 3, and then the decimal 279. How many did we want? 3 significant figures. So essentially we're going to draw the line there. And so it's currently 27, and you have to ask yourself, does it stay at 27 or round up to 28? That 9 will imply it will round up. So our answer there is 3.28. I forgot to emphasise what exponent number was sitting there at the end. It was a positive 11, so we're writing it multiplied by 10 to the power of 11. And that's to 3 sig fig. Okay, thanks for joining me. Subscribe to the channel if you haven't already, and the next video in this series is 12E rational indices. Thank you.